A volcano is a rupture in the crust of a planetary mass object, such as Earth, that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the Earth's surface. When we think of volcanoes, we think of Japan, the home of Mount Fuji, Hawaii, the chain of volcanoes in the Pacific, and Italy, the home of Mount Vesuvius, the cause of the tragic history of Pompeii. What we don't consider is the possibility that there is a once active volcano in the rural area of Challis, Idaho. The Challis Volcanics inhabit central Idaho and were formed 52 million years ago. The rocks formed are a result from the volcanic terrain created from the subduction zone. The eruption of the Challis Volcanics created intermediate to mafic lava flow and ash flows. From the eruption, igneous rock types were formed in the Challis location in Custer County. The Challis Volcanics are formed from 5 primary rock types: andesite, basalt, dacite, rhyolite, and tuffs. Andesite was formed from the eruption of the Challis Volcanic. Andesite is an igneous extrusive rock with an aphanitic texture and an intermediate composition. Its age ranges from 51 to 48 million years ago. The basalt rock, similar to andesite, was also formed from the lava flow cooling from the eruption. Since it was formed through the cooling of magma, basalt is an igneous rock. It is extrusive with an aphanitic texture and a mafic composition. Its age ranges from 48 to 51 million years. Dacites are an igneous extrusive rock with a porphyritic texture and an intermediate composition. These rocks were formed from the volcanic eruptions that created the Challis Volcanics, and their age ranges from 48 to 45 million years ago. Rhyolite is an igneous extrusive rock with an aphanitic texture and a felsic composition. It was formed from the eruption of the rhyolite domes. The last primary rock, tuff, is an igneous extrusive rock with a pyroclastic texture and a composition ranging from felsic to mafic. Tuff was formed from the pyroclastic fragments erupted from the volcano. These fragments welded and cooled together, creating tuff. To determine the rock ages of the primary rocks in the Challis Volcanics, the stratigraphy of the area was examined. The oldest rocks in the stratigraphy are on the lowest levels, and the rocks become younger toward the top because the upper layers of rocks are formed after the bottom layers according to superposition. For the Challis Volcanics, the 4 layers are composed of the basalt conglomerate and tuff breccia, andesite lava flows and tuff breccias, dacite and rhyodacite ash flows and lava flows, and lastly, dacite and rhyodacite intrusions. The basal conglomerate is called the Smiley Creek conglomerate, and it's useful because it exists among the Challis Volcanics, so its deposition must have happened during the time of the eruptions of the Challis Volcanics. The major structural features of the Challis Volcanics were formed from the subduction of the Farallon Plate and the effects of volcanism from the subduction. The first major structural feature are faults. Faults are fractures that displace the rock on either side of the fracture. The faults in the Challis Volcanic zone were made from the subduction of the Farallon Plate when the subduction became steeper. The high and low angle fractures in the earth are normal faults that form the trans-Challis fault zone. Because they tend to dip toward each other, the normal faults create a geological structure called gravens. The gravens are a depression in the earth from faults that dip toward each other with a parallel strike line, creating a long section of the Earth's crust to be displaced downward from the faults. The next major geological structure is the caldera, which is a volcanic crater formed from the collapse of the mouth of a volcano. The caldera that inhabits the Challis Volcanics collapsed from the violent eruptions from 51 to 45 million years ago and formed the peaks Van Horn Peak and the Twin Peaks. The last geological structure that inhabits the Challis Volcanics are domes. Domes are an anticlinal structure that arch upwards and are formed from the combination of lava flow. The domes at the Challis Volcanics are made of rhyolite and dacite composition.
The Challis Volcanics were part of the volcanic belt that covered the northwestern United States and southwestern British Columbia during the Eocene epoch 55 to 40 million years ago. The Eocene epoch is in the Tertiary division of the Paleogene period. These volcanics were formed by the subduction of the Farallon tectonic plate under the North American tectonic plate. The subduction started out to be shallow, but as the plate slowed, the subduction's gradient became steeper, resulting in plumes of magma that pushed up from the Earth's surface and built volcanoes from the resulting geological structures created from the subduction zone. These structures are back arc extensional basins that resulted from the westward movement of the subduction. The extensional zones consist of many high-angle and low-angle faults that make up the Trans-Challis fault zone. Alterations to the Challis volcanics are evident in mineralization. Scientists have taken aerial photos that show patches of white rocks. They have also looked at images from satellites that show areas of green alteration. They think the white patches are bleaching and an argillic alteration of volcaniclastic sedimentary rocks. There are also clay minerals that are most likely from shallow, acidic, oxidizing groundwater. However, they did not see any silica saturation, veining, or mineralization. The areas of green alterations are selidenite, which has a light apple and dark green color and alters andesite and dustite. Selidenite alteration showed up in the outcrop areas in the dustite flows and flowbreccias along the middle part of Bow Creek. They also noticed a lineaments that cross this area and think they might be related to selidenite alteration. The extensions of the northwestern trending fault near Muldoon Summit shows selidenite alteration and is filled with quartz. Scientists think this is probably related to faults and linear features that may have high permeability and fluid flow. The natural resources in this province are mining of gold, silver, copper, lead, tin, and mercury, to name a few. Another natural resource is energy, such as geothermal and wind energy. The only real natural hazard of the province are faults. In fact, in 2015, there was a 4.9 magnitude earthquake that was felt all the way in Boise.
The Challis volcanoes are a hidden gem of Idaho. Proof that millions of years ago, the Farallon plate subducted under the Northern American plate due to the convection currents in the underlying liquid mantle, moving the tectonic plates towards each other. From the eruptions, lava flow, and formation of geological structures, the primary rock types were made, and are the foundation for the faults, grabens, caldera, and domes that inhabit the Challis location now. Although most people don't even suspect that there was once an active volcano in the middle of the gem state, the evidence is in the rock types, the geological structures, the history of the Challis location, the natural resources, and the natural hazards that dominate central Idaho. The Challis volcanoes are not as famous as the more extravagant volcanoes in Japan, Hawaii, Italy, and other places around the world, but they are an important and fascinating geological area in Idaho. The Challis volcanoes aren't well known or thought of as once being active volcano terrain, but as Neil Armstrong said, geologists have a saying, rocks remember. This concludes our presentation. Thank you for your time.